Greetings to every one of you. So in this video we are going to discuss another very important concept from data structures and algorithm, that is Radix Sort. Radix Sort, it is based on the radix of the number system. For example, if you take the decimal number system, they are range from 0 to 9. So the radix of the number system, it is 10. So for example, if you write a number that is 435, this 5 refers 1's position, and this 3 refers 10's position, and this 4 refers the 100's position. So that means 4 into 100 plus 3 into 10 plus 5 into 1. So that is the meaning. So that is how actually we got the decimal number. We are using count sort as a subroutine. In order to perform the radix sort, we are going to use the count sort as the subroutine. So let us see the algorithm. Find the largest element in the given array. If it has n digits, then we have to iterate for n number of times. So for example, if the number contains 3 digits, so then we have to do the operation for 3 number of times. Second important step, sort the element based on the unit place. So this is the example that is given here. So in which you have to consider the 1's position of all the given numbers. If you say that is 405, it is 405, you have to consider this first digit, that is 5. Similarly, the first digit of the second number, that is 3 element, that is 6, 5, 3, 8, 7, 6, 9. Only we have to sort these values. So once if you get the results, so you will get the results, that is pass 1, that is you sorted all the numbers, all the elements based on this one position, you will get an output. So this output will be used as a input for the next pass. So if this is the output of the pass 1, and the output of pass 1, it is used as the input for the pass 2. If you get pass 2, the output of pass 2, it is the input for the pass 3. So similarly, third step, sort the element based on 10's place. So this output, that is S10. S1 is the output of pass 1. So S1 is used as an input for this sorting the elements based on 10's. So S10 is used for the input for sort the elements based on 100's place. Okay. So first of all, you have to consider all these the first digits. You have to consider the 10's place. Similarly, you have to consider the 100's place. So finally, you will get the result of the radix sort. So in radix sort, we are using the count sort as the inbuilt routine, subroutine, or you can call it as a function. So there are values given here. What is the range of the number? It is 9. So automatically we have to consider that is k is equal to 9. So you have to design your count array that is as k plus 1. So it is 9. You have to, that is you should have that is a 10 location. Okay. So first of all, check the 1's position and find out how many number of times each element that is occurs in this list. So 5. How many number of times this 5 occurred in this list? That you have to, that is find out. So 5, that is 1, 2, 3. 3 times. Okay. Then similarly, find out the value, that is 3. How many number of times the 3 occurred? 3 occurred 2 times. Okay. So similarly, other values like 1. 1 occurred anywhere? No. 0 occurred at last, that is also no. What about 2? 2 occurred at last, that is also no. What about 4? 4 is also 0, and similarly 6 2 times, 6 2 times, 7 one time. What about 8 one time, and 9 is also one time. So this is how we can make this count array. Okay, so after making this count array, so the same procedure. So already in the previous video, just I have explained how to perform this count sort. The same procedure, we have to find out the cumulative sum. So this is 0, and 0 plus 0, that is 0, and this is also 0 plus 0, this is 0, 0 plus 2, that is 2, then 2 plus 0, that is 2, 2 plus 3, that is 5, 5 plus 2, that is 7, 7 plus 1, 8, 8 plus 1, 9, 9 plus 1, that is 10. So now based on the cumulative sum, we have to, that is, find out the result. So the result, as far as result is concerned, you have to check it from, that is, from a right side to the left side. So that is the procedure, you know that. So start from here, that is 9. So go to the position, that is 9. What is this value? Sorry, it is 9. So it is 10. So it is make it as 9, and store the value, the position, that is 9. That is 589 should be stored in the 9th location. So similarly, go to the next value, that is 6. Come to 6. In 6 we have the value, that is 7. So make this value, that is 7 into, that is 6. So in the location 6, store the value, that is 486. Okay. So similarly, the next value is 7. Go to 7, location 7. 7, we have the value, that is 8, and it should be, that is reduced into, that is 7. Location 7, store the value, that is 387. 387. So then next one is that is 158. 158, that is 8. Come to the location 8 and reduce this value, that is 9 into 8, and now store the value, that is 158 in 8th location. Okay, so this is over and this is also over. Now this is 3. Come to 3, location 3. So reduce this value, that is 1. Go to 1, store the value 043. Store the value 043. Okay, then the next value, that is 5. Go to 5, location 5, and make this value, that is 4. Go to 4, store the value, that is 185. Okay, so then it is 6. Go to location 6. Go to location 6 and reduce this value, that is 5. Go to location 5, store the value 086. Okay, so similarly the next value is, it is 145. So go to location 5. Location 5, it is 4, already 4, now 3. Location 3, 145. Store the value, that is 145. So similarly now it is the location 3, that is 0 2 3. Go to location 3. Location 3, that is 1 here, make it as 0. In the location 0, store the value, that is 0 23. And here it is 5. 5. Go to that is location 5, it is 3. Reduce the value, that is 2. The location 2, store the value, that is 405. Okay, so this is pass 1. This is the output of pass 1. So we can check this very well. We can check the position of this unit digits. Okay, so there is 3 3 5 5 5 6 6 7 8 9. So now this is the input for your further calculation, the next calculation. So now find out the frequency of these digits, the second digits. So check this second digits. Okay, how many number of times this 2 occurred? So 2 occurred 2 occurred only one time. Similarly 4, check the 4, value 4. The 4 occurred 2 times. So similarly 0, okay, check that. The second position, that is 0 occurred, that is only one time. So similarly, that is 5 occurred only one time. 5 is here only. So similarly, that is 5 only. Then what about this 8? So 8 occurred 5 times. So 5 times occurred. So now we have to find out the cumulative. So write down the value, that is 1. Add this value with this. 1 plus 0, that is 1. 1 plus 1, it is 2. 2 plus 0, that is 2. 2 plus 2, that is 4. 4 plus 1, 5. 5 plus 0, 5. 5 plus 0, this is also 5. 5 plus 5, 10. 10 plus 0, that is 10. Okay, this is cumulative. Now we have to find out, we have to go and check the second digits. Second digits, we have to what's that? Right, we can start it from the right hand side. Check this value. It is 8. So go to the location, location 8. So what is the location 8? Location 8 is here, and we got the value, that is 10. So 10 should be, that is what's that? It is reduced to 9. So store the value, that is 589 in the location 9. 589. What is the second value? This is 5. So go to location 5. Go to location 5, and the value is already, that is 5. Reduce the value, that is 4. The location 4, store the value, that is 158. 158. So then similarly, it is 387. So 387. 8. Go to 8 location. Go to location 8. In 8 the location, we have to store this value. That is what's the next value? That is 387. 387. Then the next value, it is 486. Okay, so go to location 8, and the value is it is 8 now. Reduce the value, that is 7. Go to 7, location 7, store the value, that is 486. Okay, then it is 086. That is go to again come to a location, that is 8. So the previous value is 7. Now reduce it into 6. Go to 6, store the value, that is 086. Then again come to this location, that is 185. 185, go to 8. Again the value, that is 6 is reduced into 5. In the location 5, store the value, that is 185. So similarly, is it clear? Okay. So similarly, the next digit is 4. So go to, that is the location 4. Okay. We have the value, that is 4. 4, reduce the value, that is 4 into, that is by 1, that is 3. Go to location 3. Location 3, store the value, this is 145. 145. So the next value, it is 0. Go to 0, location 0. The value is 1 here. So reduce the value 0. So in the location 0, store the value, that is 405. Okay. Then the next value, it is 043. That is go to location, that is 4, and reduce the value, that is it is 2. We have to store the value, that is 043 in the location 2. So this must be, that is stored in location 2. So this is 023. So go to location, that is 2. Reduce the value, that is by 1. So store the value in 1, location 1. It is 023. So now this is the output of the past 2. You can very well verify. It is 0, 2, 4, 4, 5, 8, 8, 8, 8, and this is also 8. Okay. So now this is the input for our next calculation. So we have that is how many number of times the first digits occurred. See, for example, 0 occurred 1, 2, 3 times, that is occurred. So similarly for 1 occurred 3 times. So 1, 2, 3 times. 0 occurred 3 times, and this 3 occurred, that is 1 time. 2 occurred nil, and 4 2 times, 5 1 time, and remaining all other digits are 0. Okay. So now find out the cumulative sum. This is 3. 3 plus 3, that is 6. 6 plus 0, that is 6. 6 plus 1, this is 7. 7 plus 2, this is 9. 9 plus 1, this is 10. 10 plus 0, this is 10. 10 plus 0, 10. 10 plus 0, 10. 10 plus 0, 10. So last values, all the values are, that is tens. So this is the cumulative sum. Now you have to, that is perform your sorting based on the hundreds place. Okay, so find out the value. You have to start it from right side. So check this 5. Okay, so go to just location, that is 5, and reduce the value. So there is 10, reduce the value, that is 9. Store that value in the location 9. So 589 will be stored in the location 9. Okay, so similarly the next value, it is 387. Okay, this is 5, this is 3. You have to consider only the digit, that is the place 100. Okay, so go to 3, location 3, and location 3 we have the value, that is 7. Reduce the value by 1, that is 6. Go to 6 location and store your value, that is 387. So similarly next one is 4. Go to 4, location 4, the value is 9. So reduce this value, that is 8. In location 8, store the value, that is 486. Location 8, 486. Again go to this value, this is 0. Go to 0, position 0. What is the value? That is 3. So reduce the value, that is 2. In location 2, store the value, this 0, 86. Okay, so similarly the next one is 1. Go to 1, location 1. What's the value? It is 6. Reduce the value, that is 5. In location 5, store the value, this 185. Next value, it is 156. Go to 1. What is the value? That is 5. Reduce the value, that is 4. Go to 4, store the value, 158. Then similarly 145. Go to 1. Okay, reduce the value, that is 3. Location 3, store the value, that is 145. So similarly 0. Go to 0. It is already, there is 2. Reduce the value, that is 1. In location 1, store the value 043. So similarly next one is also 0. So go to 0. What is the value? That is 1. Reduce it by 1, that is 0. So in the location 0, store the value 023. Okay, so what is the next value? That is 4. Okay, go to location 4, reduce the value, got 8. It is reduce the value, that is 7. Location 7, store the value, that is 405. Okay, is it clear? Now actually we have sorted the entire list. So initially, that is this is pass 1. Based on that is ones place, we sorted the value, sorted the element, and based on 10 we sorted the elements, and finally based on 100 we have sorted the element. It is totally sorted. Okay, so this is how we can perform this Radix sort. So the Radix sort can be performed with the help of the count sort. As far time complexity is concerned, in case of count sort, it is order of n plus k that we already discussed while discussing about count sort. So in this case, we have performed n number of times the count sort. It depends upon the number of digits of the given element. Okay, so if the number of digits, in this case it is 3, so we have performed count sort 3 times, so that it can be written as, that is order of d into n plus k, where this d refers number of digits. So as far Radix sort is concerned, the time complexity can be written as order of d into n plus k. So this d refers number of digits. It is number of digits. So in this video I gave the introduction about Radix sort, and I explained this algorithm, and also I explained the algorithm with the help of this example. I hope you understood the concept. Thank you for watching. Thank you.